Hello, my dear students. So today we are going to continue our paper, which is May June 2024, P21, and it's our third part of the video in which we will solve the questions from 21 till 30. So in question number 21, it states that which region of the electromagnetic spectrum is used for detecting fake bank notes. Okay. So for detecting fake banknotes, we are using ultraviolet rays. So that is the use of it. Actually, when we are using it, so it's very easy for us to detecting the fake banknotes. In question number 22, a sound wave travels at 330 meters per second. The distance between the center of a compression and the center of nearest rarefaction in the sound wave is 2.5 centimeter. They want that we will calculate the frequency of the sound wave. Now, this is the speed, but did you notice here that speed is in meters per second, but here the distance is given to us in centimeters? Another thing, they're talking about compression and rarefaction. What a compression on a sound wave is that a compression is the area on a wave in which the particles of the mediums, they are very close to each other. We are going to represent it with the letter C. And the particles, if they are further apart, then that area is called rarefaction. So they are saying that the distance between the center of a compression and very next rarefaction is 2.5 centimeter. But you know that what a wavelength is, we need a wavelength also to calculate the frequency. The wavelength is the distance between two successive crusts or troughs, and in this case, two successive compressions or two successive rarefactions. So we need this distance also from the one center of one compression to the center of the next compression. So 2.5 and 2.5 will give you 5 centimeter, right? But 5 centimeter, we are not using it. We need to convert it into meters, right? So how to convert it into meter? We will convert it by dividing this factor with 100. So you will get the answer 0.05, right? So now this is in meters. To calculate frequency, we have equation V over lambda. Okay, speed over wavelength. Now we have both the terms, so it's very easy for us to calculate 330 divided by 0.05. So our answer will be 6600 hertz. The option in it is correct. Next question number 23. Which waves are used in the medical scanning of soft tissues? It's very easy. That is ultrasound. We are using ultrasound for the medical scanning of soft tissues. Question number 24. Which row describes suitable materials for use in a temporary magnet and in a permanent magnet? So what a temporary magnet is? It's a magnet which can be easily magnetized and demagnetized. So the materials which can easily magnetize and demagnetize, those materials are used to make temporary magnets. And for permanent magnet, we are using the ones which cannot be easily magnetized and demagnetized. So the property of soft iron is that it can be easily magnetized. That's why we are also using them as a electromagnets. So from A and B options, we have to select. As I told you that soft iron is used only for temporary magnet, not for the permanent one. So the next example is steel, and steel is a material which can retain its magnetism for a long time. So option number B is the best answer. Next question number 25. A magnetic field is represented in the diagram by magnetic field lines at a point. At which point is the magnetic field strongest? We are talking about that at which point magnetic field is strongest. So magnetic field is stronger where the lines, magnetic field lines, they are very close to each other, right? And it is only possible near the source. Okay. And if we will see all the options A, B, C, D, A option is the one in which the field lines are very closer to each other. So here the magnetic field is strongest. Next question. A student determines the resistance of resistor R. She uses resistance of a resistor R and she uses a circuit including voltmeter and an ammeter. So which circuit does she use? Here, first of all, we need to know this thing that ammeter should always be connected in series and voltmeter should be connected in parallel with the circuit components. So with this concept, if we will move on, so we will take a look on different diagrams. Here, voltmeter is not in parallel, so this is wrong option. Here, ammeter is not in series, so this is the wrong option. Here, both of the things, voltmeter and ammeter, they are placed wrongly. Voltmeter should be connected in parallel and ammeter should be connected in series. So this option is also wrong. So D option, here both of the things are correctly placed. So ammeter is connected in series while the voltmeter is parallel with the resistor. So our D option is correct. Next question. A diode and a resistor are connected across a variable DC supply. It's a variable, right? Terminal X is initially positive and at a maximum value. Like terminal X is positive, it means that with respect to X, the other one will be at negative terminal, like Y should be at negative. So the potential difference across X, Y is adjusted so that it changes as shown by the graph. So here this is the graph which is given to us, moving from positive toward the negative terminal. Like it's like they said, it will be on both of the axes, like switching the axis positive side and the negative side. So this graph is between PD and between time. So potential difference and time. Now, what they want, which graph shows how the current in the circuit from X to Y varies during the same time interval. So now we need to see that how current varies. Initially, this graph is for potential difference, but we need the graph for current now. To select the shape of the graph, we should know what is forward bias and what is reverse bias. Okay. So in forward bias diode, the diode should be connected in such a way that the positive terminal should be connected to the p-type side. This is the p-type side of the diode and this is the n-type side of the diode. So positive terminal should be connected to the p-type side and negative terminal should be connected to the n-type side, but here it's opposite. So in forward bias condition, the diode will be diode allow the current to pass through it. Okay, but here the diode is reverse bias. So in the reverse bias situation, the n-type side is connected to the positive terminal of the battery and p-type side is connected to the negative terminal. So here it will not allow the current to pass through it. So initially, what happened that the current will not flow through the diode. Okay, so when the current will not flow, so we will see in option A, B, and C that the current is flowing. But in D option, the current is not flowing initially. So this D option is correct. Later on, when this side is negative and positive, then it will be easy for us to detect, to say that yes, it will move on and the current will flow through it because it's varying supplied, right? So here D option is correct. Moving on towards our next question, that is 28. When a conductor in a complete circuit cuts across a magnetic field, a current is induced in a conductor, right? So they already tell us that when there is a cutting of magnetic field lines, the current will be induced. So now they want that which statement about the induced current is correct. Number one, the induced current is in the same direction as the motion of the conductor. So for this, let's draw one diagram. This is a conductor. Okay. Here I will attach an ammeter, any multimeter you can attach. Here we have a magnet which is moving inside and outside because we need the cutting of field lines. So the EMF will be induced and current will be induced in it. But as in the first statement, they are saying that induced current is in the same direction as the motion of the conductor. So conductor is moving from this. Not necessarily the current will be like this. Okay. So current is not like that. It should be in the direction of the motion of the conductor. It's not possible at all. Okay. It's simple circular, and if the magnet is moving inside and outside, so how the direction of current will be like this? It's in circular path, right? The next thing, the induced current is in the opposite direction to the motion of the current. Again, not possible. The direction of the induced current is in the same direction as the magnetic field. No, not possible because magnet is like this. So these are the magnetic field lines. So the current direction is not in the direction of magnetic field. Yeah, so fourth statement is correct. It states that the direction of induced current opposes the change, causes it. That is the Lenz's law. So Lenz's law states that the direction of induced current is such a way that it opposes the cause which produces it. So D option in it is. So D. Next question. In the next question, they are saying that the diagram shows a solenoid carrying an electric current. So which row compares the strength of the magnetic field due to the solenoid at points Y and Z with the strength of the magnetic field at point X? Okay. So we need to tell that we are actually comparing here the magnetic field of X with the magnetic field of Y and Z. You know, inside what happened that inside the magnetic field, inside the solenoid, the magnetic field lines are straight and very close to each other. So the magnetic field strength is much more in between the solenoid as compared to the outer ones. Okay. So outside the solenoid, the field lines are further apart from each other. So the magnetic field is not stronger here. Okay. So now what we are going to do here, that we are going to see the options that magnetic field strength at Y, they're talking about Y point, is equal to X or greater than X. As it's both of the points are inside the solenoid, the field line or magnetic field strength that is equal to X. So we should select A and B. From A and B, definitely. So C and D options should not be possible for us. The next, magnetic field strength at Z, that should be less than, it should not be greater than, because the field lines are further apart from each other. So for 29, A option is correct. Okay, not B. Next question. Question number 30 now. Here there is a conducting wire and it is placed between the poles of a magnet. So when an electric current in the wire is in the direction shown, this is the direction shown to us, right? Then the force on the wire acts out of the page, like out of the screen towards us. That is the direction of force. So there are three statements of different conditions, and how the wire is affected are given. So they want out of these three, you can select that which statements are correct. So one by one, we will see that which statements are correct now. Number one, when the current is toward the top of page and the direction of magnetic field is unchanged, the force produced acts into the page. Now, you know that there is one concept here. You will see that the magnetic field is right now from north towards south. And in first statement, they are saying that we are not going to change it, but they are just changing the direction of current, right? So if only one thing is changed from current and magnetic field, then the direction of force is reversed. Okay. So right now in the previous situation, the direction of force is out of the page. So it means that if they are changing the value of current, the direction of force should be into the page. So this statement is correct here. Then next statement, we will check now next statement what it is. When the current is toward the bottom of the page and the magnetic field is reversed, the force produced acts will be again into the page. Right now, let's change the situation according to our new statement. They are saying that now we are changing the magnetic field, but the direction of current remains the same. So again, only they have changed one thing. Okay. So if they will change one thing like now the direction of magnetic field is reversed, but not the direction of current in the second statement. So again, the direction of force which is acting on this wire should be opposite to this. So it is into the page. So here they mention that it is into the page. So second statement is also correct. Then final statement, when the current in the wire is alternating, like alternating means that once they will go down, in the next half they will move up, like it's positive and negative, both peaks are there, right? So it is moving, it is like switching after half cycle. So positive and negative, both the peaks are there. So value of direction of current is keeps on changing. So the wire vibrates into and out of the page. Yes, definitely. If the value of current is keep on changing, then the force on the wire will also change. So with the direction when it is downwards, it is moving out of the page. And when the direction is reversed, it is upward, then the direction of the force acting on this wire will be into the page. So this third statement is also correct. So if we will see from the options, all these statements are correct. So 1, 2, and 3. So it's A option. I hope you like my this video, and it's like these questions will be now easier for you to solve. Take care, Allah Hafiz. For next questions, please watch my next video. Take care, Allah Hafiz.